Okay, so now what we're going to do is we're going to take this system, right, and we're going to write it as a matrix, and then we're going to use the Gauss's method to row reduce and put it in echelon form. Okay, so the first thing is again, notice that the x's and the y's and the z's are lined up, and so this would give us the matrix. What? It's going to be, let's put in zeros. So this is going to be 0x, right? This is going to be plus 0z. This is going to be plus 0y, right? So let's just fill in the numbers, okay? And so what that's going to give us, it's going to give us 1, 2, 0. And I'm going to put a line here, 4. And I'm going to put 0, 1, -1, 0, and then 1, 0, 2, 4. Okay. Now, this is what we call an augmented matrix. Okay? So we can abbreviate this here. Now, the vertical bar reminds the reader the difference between the coefficients on the left side and the constants on the right. Okay, so this is called an augmented matrix. So when you have the bar with the, showing that, you have an augmented matrix. Okay, so now what we're going to do is we're going to row reduce this. Okay, so now wherever there's a 1, that represents a variable or any non-zero number. Okay, so here we need to get rid of that 1. So what I'm going to do is I'm going to do -1 row 1 plus row 3. Okay, so again, I'm going to do the exact same thing I did before. So I'm going to do -1 plus 1 is 0. So I'm going to just rewrite the augmented matrix except for this row. So this gives me 1, 2, 0, 4, 0, 1, -1, 0. And now this is going to be 0, right? So this is going to be 0. And then -2 plus 0 is -2. And then -2 times 0 is 0, plus 2 is 2. And then -4, right? -4 plus 4 is 0. So now my new augmented matrix is this. Okay. Now what I'm going to do is, now I've got, this is a 1 and this is -2. So I want to get rid of that -2. So what I'm going to do is, now I'm going to do what? I'm going to do 2 times row 2 plus row 3. Okay, now again, first 2 rows stays the same. 1, 2, 0, 4, 0, 1, -1, 0. Now, this is going to end up being 0, right? Okay. This is going to stay the same, so it's still going to be 0. Then this is going to be what? 2 times here, so 2, so see this 0, so 0 times 0 is 0, so it doesn't change anything here. So if I do 2 times 1 is 2, plus -2 is 0, 2 times -1 is -2, -2 plus 2 is 0. And look at that. I get this as my final matrix. So now notice here, each column represents a different variable. So the column 1 represents the x's, column 2 represents y, and then the column 3 represents z. So when we look at this, what does this tell us? Well, this second row tells us that, so let's just put it this way. So if x, y, and z, right? Okay, and if you want to go back, let's write this as d. Remember back to the first video. So this would say what? This would represent y is equal to z, right? So this is telling us that y is equal to z. And see also, z is not a leading variable, so it's free. So z is any real number. Okay? And then this here tells us what? This tells us that x is equal to negative 2y plus 4. Okay? But again, since y is equal to z, we could put it that way. Okay? And then again, the way we would write this in our set notation is going to be, well, it's going to be negative 2z plus 4, comma, z, comma, z, such that z is a real number. And that describes our solution set. Now, the other thing too is, so the matrix notation also clarifies the descriptions of the solution sets. Okay. Let's see here. Now, in the previous one, well, you know what, I'll say that for another video. Okay, I'll just stop here.